What's poppin', dogs? Mr. Allen here talking exponential growth with compound interest in this video. I got two scenarios that we're going to compare, and you're going to be surprised as to how drastically different the outcome is. So after dropping straight out of Compton, great album, Ice Cube invested $1,000 in an account earning 10% annual interest. He was 19 years old at the time. Very smart move, Ice Cube. Now, Dr. Dre waited until he was 35 to do the same. How much is each account worth when they are 60 years old? Okay, so how are we going to map this situation up? Well, they invest, okay, so we're going to write a function here, A of t, amount of money after a certain amount of time. They each invest $1,000, and they are each earning 10% interest is what it says here. So 1.10 or 1.1, I'll do the 10 so we can see it. 10% as a decimal, you got to move the decimal back 1, 2, boom, 0.1 is your decimal then. And then we're going to raise it to the t, and the t is going to be different for each one. So let's write one function for Ice Cube. I will use blue because I feel like that reminds me of ice cubes maybe, sort of. Water, frozen, ice cube. All right. So Ice Cube. Should we do cube as a function of time? That's his money. We got $1,000. And how long is he investing it for? He was 19 years old at the time to 60 years. Is it going to be, what, 41? Right? So raise to the 41 power, 41st power. And then Dre, I'll go green for Dre here. No reason. We got T. And then we have $1,000. 1.10. And he was 35. So it's like you're still, pretty young, right? Still young, hip. I'm 36. He's 35. 25 years then, right? 60 minus 35 is 25 years. So what's the difference here in time? The time difference is 16 years. So let's just jot that down for fun. 16-year difference. Okay? So not a crazy difference in time, but somewhat significant. So let's see what these accounts are worth, right? So I'm going to plug that in. I got $1,000 and then 1.1 raised to the 41st power, hit enter, 49,785. And then Dre is $1,000 still, same growth, 10%, and we're going to raise that to the 25th power because he was 35, 60 minus 35 is 25. Hit enter, and I've got $10,834. If I were to divide these two, let's see how many more times. It's about 5 times more, right? Yeah, 4.59. That is significant. We're talking 16 years, right? It's not even double the time, but it's almost 5 times the amount of money due to the compound interest. So when your money makes money, the next year, the money that made money is now making money. And then your money is making money off the money that made money, off the money that made money. And then that happens 41 times over there over the course of Ice Cube's investment, only 25 times for Dre. So it's going to take him a lot more time to catch up because Ice Cube was smart, did at 19 years old. And you can actually, check this out, we could actually write a function for this and take a look at a table and see how different it is over time. Like, what if he had success at 15 years old and he invested it then? Like, how much more money would you really make, right? Let's take a look. So I'm going to go to my y equals here and type this in. We got $1,000, right? The 1.1, the 10% growth. And that's actually, I'd say, pretty favorable growth, but between 8 and 10% is like your general growth over a 30-year period average per year for the S&P 500. You can invest in an ETF, an index fund, and it will mimic the S&P 500 and generally grow between 8 and 10%. You got to adjust for inflation and other things like that. 10% is a nice round number, and it looks pretty cool when it grows that much. Anyways, we're going to raise this to, and essentially, how do we get these exponents? I took 60 minus the age, and I did 60 minus the age here. So let's do this, 60 minus the age, okay? X will be our age. So now we can look at a table. Our X values are the age, and the Y values, the outputs, are what the account's worth, okay? So I'm going to hit second window to go to my table to set it. I'll put it at 0. Our change is by 1, and now I can hit second graph, and we can look at this table. So now I have, okay, if we were invested at 1 year old, what is that? $276,800. That's crazy. This was about 50,000. This is about 10,000, right? If we go down to, say, 10 years old, we've got $117,000. Okay, so maybe, how about this? Your parents open an account for you when you're born. They throw $1,000 in there. When you're 60 years old, it's going to be worth like almost $300,000. So they do it right when you're born at 0 years old. And then check this out. We can take a look at our 19. We should see our value right there. Right there it is. There's the 49,785. And if I go all the way down to, we said 35 years old, there's our 10,000, right? And anywhere after. So the numbers just keep decreasing as the age increases because it's less time growing at that 10% rate. And your money is not making as much money off of that money because there's not as much money making money off of money. Anyways, there we go, guys. Compound interest, Einstein called it the eighth wonder of the world. I believe it was the eighth wonder of the world, he said. So time in the market, not timing the market. That's how I live my life. But you do you. Invest early if you so choose. There's risk to everything. I got to do like a disclaimer, I think, when I'm talking about money here. But kind of a cool thing to look at and a nice little application of exponential functions. Hope you guys enjoyed that. If you got any questions, pop in the comments, request for other videos, let me know, or just want to say what up, pop it in there, what up, and have a great day. See you later.